Cise is a Boston University research center that has more than 40 faculty affiliated with the center, and is focusing on computational science and engineering. Much of the work that is done at the center, particularly the computational work, is supported by the Mass Green High Performance Computing Center. The Cise faculty work on a large number of different application areas, from modeling protein interactions to optimizing data centers and the recent smart electric grid, to detecting dementia using medical data and even predicting disease outcomes. One of the cool research areas that we work in Cise involves learning from biological beings, from humans and from animals, how they navigate in very complex terrains, and then taking these lessons and applying them to autonomous systems. So our goal is to enable autonomous systems to be able to navigate in areas that are unpredictable, not very structured, with dexterity and ability that humans and animals exhibit in these types of environments. In doing this work, we are collaborating with a number of people, including people in neuroscience, including roboticists and applied mathematicians, who develop some of the methods that are then used in autonomous systems. Another area of work at Cise involves transportation networks, analyzing these networks, understanding traffic patterns, learning from traffic data that we are collecting and others have collected, and trying to figure out ways in which we can relieve congestion whenever that occurs using a variety of methods. One of the areas where work is going on is in developing autonomous vehicles where the vehicles talk to one another and are able to coordinate in the way they are using the transportation network, so as to the extent possible try to minimize congestion.
Hi, I'm Ayşe Coşkun. I'm a professor of computer engineering at BU, and I'm leading a project on integrating data centers into emerging power markets. And in this way, data center can not only reduce its energy cost, but also provide reserves to the grid, which is particularly important in presence of volatile intermittent renewable generation. And Cise was a huge enabler in this project because I met my colleagues in mechanical engineering and systems engineering through Cise events. And MGHPCC is our instrument or playground. We not only look at their data for understanding power performance trade-offs in data centers, but also we conduct a number of our experiments on the MGHPCC resources.
I'm Vivek Goyal, and I'm a professor of electrical and computer engineering. My group works in computational imaging with an emphasis on extracting useful information from very weak and commonly ignored signals. An example of a very weak signal is to have a LiDAR system operating at such low illumination power or such long distance that just a handful of photons per pixel are detected from the scene. And these are easily lost in the number of photons detected from ambient light. An example of an ignored signal is the penumbra created by light from outside the field of view. We've shown that the photographer's adage, if you can't see the camera can't see you, isn't completely true when you throw computation into the mix. We're also working with long-wave infrared thermal emissions and particle beam microscopes. Shared computing resources are essential to our algorithm development and evaluation. Cise doesn't just support us administratively, it also provides an intellectual home with professional development activities and opportunities to interact with researchers with overlapping interests.